Hello everyone, good evening and welcome to the fifth week of the live interactive session for the course on Integrated Waste Management for a Smart City offered through NPTEL. My name is Sedu Vinayagam and I'm a PhD scholar in the Civil Engineering Department at IIT Madras. So we'll start the session by looking at what were the concepts that we learned in week 5 of this course. So lecture 21, which is the first lecture of this week, covered what is called as a material mass balance. So it is a method that we use to determine the amount of waste that is being, or to determine the quantity of waste that is being generated. And then we looked at source handling and separation methods, right? How it helps, and also how to design the collection systems. Then in the second lecture of this week, in 22, we looked at problem of vehicle routing, right? So this is with respect to transportation of the collected waste. So how we can do that efficiently? So that is a vehicle routing problem. So we want to optimize the total distance or the total time that is spent in transporting the collected waste. And then we also looked at some basics related to transfer stations and how they help, right? And then moving on to lecture number 3 of this week, we looked at economics of transfer station, right? So whether we have to go for a transfer station or go for the direct haul option, and also then looked at solid waste collection case studies from different parts. And in the fourth lecture, we looked at solid waste generation and collection case study case problems related to this particular aspect. And then in the final lecture of this week, we looked at how source separation and compaction impacts the waste collection systems. Right. So with that overview, we'll look at some of the problems related to these concepts. So the first question for this week is, which among the following could be an example of the rate of generation of waste material within the system boundary? So the options are wastewater, storage, leachate, and biological transformation. Right. So here we are talking about a system could be anything that is of our concern, what we are designing for, right? It could be a specific landfill site, or it could be a whole city, right? So the system is based on what we are interested in. So once we have defined the system, so we'll get a boundary or the region that we are interested in. So here we are asked about what is the rate of generation of waste material within the system boundary. So when you look at a system, there can be some material which flows into the system, some material which flows out of the system, and then there could be some material which can be generated within the system. And from our mass balance, we know that these the inflow and the outflow, or the difference between them, is equal to what is called as the change in storage, or that must be equal to what is generated in the system. So we have different options given here. So which of these could be generated within the system and stays within the system, right? So we have wastewater, storage, and leachate, and finally biological transformation. So the answer to this is option D, biological transformation. Why A, B, and C are not are not generation within the system is because wastewater and leachate are materials that flow out of the system, right? So wastewater, leachate, recyclables, vapor, all these are materials that will flow out of the system, whereas storage is what is getting accumulated, from whatever is coming in, whatever is getting accumulated within the system, that is what we call as storage. Whereas biological transformations and other processes such as incineration, so those things lead to generation of materials within the boundary, right? So that's why option D is the correct. Is that clear? Okay. Moving on to question number two. 10 moles of A were present in a system initially and 5 moles are added to it. It follows the reaction 2A gives 1B. What is the number of moles of B produced? Options are 2.5, 7.5, 15, and 25. So please work it out and you can answer in the poll. I'll just create a poll quickly. Right, we have been given a reaction to A gives B, right? And we know what is the total amount of A present in the system. The question is how much of B will be produced. We'll just take some 30 seconds, right? It's not that difficult, so quickly you can answer in the poll. Or you can use the chat as well if you are comfortable with that. You can answer in the chat also. Any answers? Okay, so the correct answer to this is actually option B, 7.5 moles. Okay, so there is so we'll see how to solve that. Just 1 second. Okay, so what we know from the given reaction is that 2 moles of A will produce 1 mole of B, right? So this is what the given reaction tells us. So in other words, for 1 mole of B, we need, or 1 mole of or 1 mole of A will produce half a mole of B. So we can say it in this way as well, right? 2 moles of A will give 1 mole of B, or if we have 1 mole of A, that is equivalent to saying half a mole of B will be produced. Now, what is given in the question? Like 10 moles of A were initially present, right? So we'll say quantity of A. So 10 moles were initially present, and then 5 moles were added to it. So totally there are 15 moles of A in the system, right? So that is also given. So we know 15 moles is there. And question is how many number of moles of B will be produced. So we know 1 mole of A will give half a mole. So 15 moles will give 15 by 2 moles of B, right? So quantity of B that will be produced will be 15 by 2. So which is 7.5 moles, right? So that's how we do it. Any questions? Is the solution clear? Why it is 7.5? Anyone? No, this was not discussed in the lecture, but this is the basics. So this is just based on the mass balance, right? So from two, for 1 mole of B, you require 2. So if you have 15 moles of A, from that you can produce only 7.5 moles of. Okay, any questions? Okay, if there are no questions, we'll continue. Okay, so question 3 is large containers for waste collection system can be used by which of the following bodies? So options are high-rise apartments, duplexes, single residences, and low-rise apartments. So again, here we are talking about waste collection. So we want to decide what should be the size of the storage that we want to use to collect this waste. So the options how they are differing. So they are differing based on the amount of waste that will be generated, right? So that is we can say it is a function of how many people are going to be there. So high-rise apartments, more waste will be generated for a given unit of time, whereas duplexes, single residence, and low-rise apartments are comparatively are going to produce lesser amount of waste. So here we are looking at large containers. So which means it is appropriate for areas which is going to produce large amounts of waste. So that's why the option correct answer to this is high-rise apartments. So we looked at this in one of the lectures. So where curbside pickups are more suitable for single residences, duplexes, low-rise apartments, and some small, medium-rise apartments. Whereas we go for large storage containers in medium-rise apartments, high-rise apartments, commercial and institutional buildings, right? So because there is going to be more amount of waste generated, or more rate of waste will be generated in those but in those cases. So that's why we go for large containers. Any questions? Okay, so we'll move on to question number 4. Determine the number of houses in a colony with an average occupancy rate of 4 people per house that generate 3 containers volume of waste per week after compaction. Okay, so each container's volume is 7.5 cubic meters, and the solid waste generation rate is 0.45 kilogram per person per day. The compacted density of solid waste is 300 kilogram per meter cube. Okay, so we want to determine how many houses are there in a particular colony, that and the amount of waste generated is given in terms of the volume of containers, and we also know the per capita waste generation, and also the compacted solid waste density. So the options are 425 houses, 536 houses, 200 houses, and 150 houses. Yeah, so please take a minute to solve it, and then you can answer in the poll. If the question is not clear, please ask. Yeah, you can answer in the poll or in the chat, whichever you're comfortable with. Okay, C, we have an answer C. Okay, we'll see if it is correct. Anyone else? Any other answers? Maybe 30 more seconds, we'll wait.
A.
A, okay, 425. Okay, we have some varied answers. All right, so we'll see what the answer is. It is actually option B, 536 houses. So we'll see how to solve that. Okay, so how do we solve this? So what the question is asking is we need to determine how many houses are there in a colony that is generating a given amount of waste, right? So first we need to know what is the total amount of waste that is being generated. So it is given in terms of the volume. So we are told that per week there are 3 containers volume of waste is being generated after compaction. Okay, so we know the total volume. So what is the total volume? Total volume of waste uh, is equal to 3 containers, and the volume of each container is actually 7.5 cubic meters, right? So that is how much? 22.5 cubic meters, right? Let me write it as an equation. So 3 times 7.5, so that is 22.5 meter cubed. So we know this. So 22.5 meter cube of compacted waste is being generated. So what is the total weight of waste that is being generated? Weight of waste, and also remember that this is the waste generated per week. Okay. So to know the weight, we know the volume. So to know the weight, we need the density, right? So the density is given here. It is given as 300 kilogram per meter cube, and that is also for compacted. That is a compacted density. So to know the total weight, we need to multiply the volume with the density. So that is 22.5 times 300, right? So that gives us 6,750. And what is the unit? It is kilograms, right? And this is also again per week. So this is the total amount of waste that is being generated per week, or in terms of per day, how much waste is being generated. To know that, we should divide this by 7, right? So if we divide that by 7, we get 964.29 approximately. Okay, so this is the total amount of waste generated in a given day on average, right? So this much information we know. Now, to know how many houses are there, so how we could do that, we know the per capita waste generation. So each person in one day generates 0.45 kilograms. So that information is given. So number of people in the colony, so that is what? So that is this total weight, which is 964.29 kilograms, divided by the per capita rate 0.45. So this will tell us how many people are there in that particular colony. Say 964.29 by 0.45. So that is approximately 2143. Okay, 2143 persons are there in that particular colony. So, but the question is asking how many households are there, and also we know that each, on an average, each household contains 4 people, right? So to know the number of houses, we need to divide this number of persons by 4, so that we know how many houses are there. So that is 2143 divided by 4. So which is again approximately 536 houses. Okay, so that's how we arrive at the answer. Any questions? Was the process clear? Right. So what we did, so we first found out what is the total amount of waste that is being generated. So to do that, it was not directly given to us. So first we found what is the volume, total volume of waste, right? So we were given in terms of containers, 3 containers. So we also were given the volume per container. So we multiplied that to get the total volume of waste that is being generated in a particular week. And then we also converted that into the weight, right? So to do that, we multiplied the volume with respect to with the density. So that gave us what is the total weight of waste that is being generated in a in a week. And then we converted that to per day waste generation. So that is by dividing it by 7. Okay, and once we know that, we to get the number of people in the colony, we divided this weight of waste generated per day by the per capita generation rate, right? So that will give us the total number of people living in that colony. And from that, to go into the number of houses. So we divide that by the occupancy rate. How many people are there per household? So that gives us the total number of houses. Okay, if you have any doubts, you can ask. Okay, if there are no questions, we'll move on to question number 5. Which of the following data is required to design a solid waste management system? Options are quantity of solid waste generated, quantity of the solid waste collected, quantity of solid waste separated, and option D is all of the above. Right. So to design for a good design of a solid waste management system, it is necessary that we know actually all of these three quantities, how much of the waste is being generated, so that we know what should how many trucks are needed, right? So like your total amount of waste generated will tell you what should be the scale at which you will be operating, right? So how much waste you'll be dealing with. So the quantity of waste collected, so that is how much is going to reach, or that is the how much waste that will need to be collected, or how much that will be taken by the waste management system. And then the quantity of waste separated. So if you do the source separation properly, so then you know how much will be going for recycling, how much will be going for incineration or other process, and how much will end up in a landfill. So you need to know what will be the quantity of waste that is getting separated, right? So all these three impact the different aspects of the waste management system, and it is necessary that we know about all these three quantities, right? As we saw in the lecture, so the knowledge of the quantities of the solid waste generated, separated, and collected for further processing is fundamental to the design of a solid waste management system. First we need to know what we are dealing with, right? Only then we can design for that. Okay, any questions? All right. Moving on to question number 6, similar to the question that we saw earlier. So, question 2. So, 20 moles of carbon react with 40 moles of hydrogen, H2. And how many moles of CH4 will it produce? Options are 5, 10, 15, and 20. I think now you will be able to do this. This is similar to how we did question 2, right? So, please try and then you can answer either in the poll or in the chat. We have 20 moles of carbon, 40 moles of H2. So question is how many moles of CH4 will this produce? Okay, any answers? Anyone? Okay, so we'll see the answer. So the answer is option D, 20 moles. Why is that? Okay, we'll see. Okay, so before we solve this, first we need to write the balanced chemical equation for this. Okay, so what is the balanced equation for this? So it is 1 mole of carbon plus 2 moles, just 1 mole of carbon plus 2 moles of H2, right? So that is going to give us 1 mole of CH4, right? 1 mole of methane. So this is the balanced chemical equation, right? So from this we know 1 mole of carbon plus 2 moles of hydrogen will give 1 mole. And now question is, there are 20 moles of carbon and 40 moles of hydrogen H2. So how many moles of CH4 will be there? So because 1 mole of C, and so 1 is to 2 ratio, right? So if there is one of C and 2 of H2, there will be 1 of CH4. So if there is 20 of C, 40 of H2, there will be 20 of CH4, right? So that's why it is 20. So if you write the balanced equation, so from that you will be able to answer this question. That's similar to what we did at question 2, right? As I said earlier, where we saw 2 moles of a particular element A reacts to give 1 mole of B, right? So from that we said 15 moles will give 7.5 moles of B. So similarly here. Okay, any questions?
Can you please explain?
Yeah. So this is the balanced chemical equation. Is this clear? So we have 1 mole of carbon and 2 moles of hydrogen gas H2, right? So this produces 1 mole of methane CH4, right? So this is balanced. You have so the left hand side and the right hand side, the amount of the elements present are same, right? So this equation is balanced. So from here we know for so 1 mole of carbon plus 2 moles of hydrogen will give 1 mole of CH4. If you have 20 moles of carbon, right, and 40 moles of hydrogen H2, so what how much will that give? So that is going to give 20 moles of CH4, right? It is in the same ratio, right? So 1 is to 2, it is in the same ratio. 20 is to 40 is the same as 1 is to 2. So you will get the same ratio. So this will also become 20.
Okay, okay. Thank you.
Okay. Anyone else having a doubts? Okay. So if there is no further doubt, we can continue with the next question. Okay. Question number 7. Calculate the internal storage in the above mass balance of material. So the figure is shown actually below. So we have some input, right? Some product. So 1.5 is the amount. Okay, some units, and then we have a system that has some internal storage, right? We don't know how much it is, and then there are some outputs. So some recycled material, that is the quantity of that is 1.25, the same units, and then there are some mixed waste with quantity 0.1725. So we know how much is the input, how much is the output. The question is, what is going to be the internal storage? So the options are 0.0775, 0.775, 0.05, and 0.06. Right, so we need to do the mass balance and find out what is the amount of storage in this system. Yeah, please take few seconds and I can answer it. It's very straightforward. So we know the input, we know the output. We need to balance it and then find out what is the amount of internal storage. Anyone? Any answers?
A.
Okay. Any other answers? Okay, so we have another answer A. Okay. Okay, so option A is correct. So 0.0775 is the right answer. So how do we get that? Okay, so how do we get that is like this. So we are asked what is the total internal storage. So how do we find the change in storage? So it is nothing but the difference between your input and your output, right? So you have some input and then you have some output. So the difference between what is coming into the system and what is leaving the system, so that should be present within the system, right? So that change in your system's storage is going to be this difference. So what we know, the total input is 1.5 some units, and you need to know the total output. So we have two different outputs. One is the recycled matter and other is the mixed waste, right? So we need to subtract them both, or so 1.25 is the recycled one and 0.1725. So this total or this sum is your total output. So we need to subtract your total output from your total input. So that turns out to be 0.0775. Okay, so that is your change in storage. So which is what is asked. Okay, is that clear? So this is your mass balance, right? So the total amount that is present in the system is nothing but your input minus your output, plus if there is any generation that is happening within your system, you have to also include that. But in this case, there is nothing being generated within the system. So there is only input and output. So it is only the difference between the two. Okay, so if there is no question, we'll move on. Okay, so question number 8. So this graph was given in one of the lecture, right? So in this graph, we have to identify what is this missing point identified by this question mark. So we have options: point of intersection, break even distance, break odd point, odd even ratio. So this is looking at the economics of a transfer station, whether you go for a transfer station or you go for a direct haul. So we are looking at what is the cost of the direct haul option in per mile of transferring the collected waste, and we are comparing that against what is the cost for when we have a transfer station, and they are crossing a particular point. What is the name of that particular point?
Break-even distance.
Okay, break even distance. Yeah. So any other answers?
Break-even distance.
Yeah, okay. So break even distance is the correct answer. So what do we mean by break even distance? It is that particular value of the distance at which the cost of owning and operating the transfer station is less than that of the direct haul option, right? So here in this particular point, these two costs are the same, whether you have a transfer station or you go for the direct haul option. When you have to transport your waste for this particular, whatever is this value, let us say x, for that particular distance, the cost of both the options are going to be same. It's not, you can't go for either options if that is the amount of distance that you have to transfer, right? So but if your distance is anything less than that particular value x, then your transfer station cost is much higher than your direct haul, right? So the direct haul is represented by this red line and the transfer station by this green line. So the cost of going for the direct haul option is lower below this break even distance, and once we cross this break even distance for any distance that is larger than this break even distance, then going for a transfer station is will be more economical, right? So it is going to cost you lesser than if you go for the direct haul option. So the point at which these two are equal is called the break even distance. Okay, so with that we'll move on to question number 9. Which of the following are the different methods of estimation of the quantity of waste generated? The options are energy balance, material balance, load count analysis, weight volume analysis. So again, this is a multiple select question, so we could have multiple correct answers to this. So which of these can we use to quantify the waste that is being generated? So we have seen some of these methods in the lectures, some we didn't. So which of these
B,
are
C, D.
B, C, D? Okay,
Sir, B, sir.
B. Okay, so there could be multiple correct answers here. All right, so the correct answer is actually BCD. So that is correct. So material balance, load count analysis, weight volume analysis. So all these three methods can be employed to quantify waste generated. So in the previous week, actually, we did an exercise on load count analysis, right? And also this week we saw about material balance, and also we did some exercise related to material balance. So this was also discussed in the lecture. So we could use any of these three different methods. So all this will give us some estimate of the waste that is being generated. So question number 10. Which of these are the advantages of backyard composting? So options are: it provides a stabilized material for gardens. Option B is mulching in the backyard composting improves the recycling rates. C, they attract pests and flies. And D, can also use meat from the food waste in this composting. So which of these are advantageous when we do backyard composting? So backyard composting is doing a composting in our home itself.
Yes, sir.
Okay. Again, there could be more than one correct here. Okay, we have one answer in the chat, A and B. What about others? What do they think? We have an answer A, B. Anyone think C and D are advantages of backyard composting? Okay, so the answer is both options A as well as B are advantages. So when we do backyard composting, so those compost materials can be used for our home gardens, right? So we could do that. Also, we could do mulching. So mulching is we will break down the yard waste that is in our backyard, right? So and then let it compost by mixing it with the soil, so that will help us improve the rate of recycling. So this does not get into the other waste that we are doing, so it helps in the separation also, and also improves our recycling rate. But it is not, the C and D are not actually advantages, that they attract pests and flies. And D is saying that we could use meat from the food waste when we are doing this backyard composting. Actually, we do not throw our meat waste into our backyard compost, because one, it takes a long time to degrade. Two is, it also creates odor, right? So those issues are there, so we don't use meat. The only advantages from given here are options A and B. Okay, any questions? Okay, so moving on to question 11. Curbside pickup is a method of source handling and separation of solid waste. Is it is the statement true or false? Okay, we have one answer. Is this statement true or false?
True, sir.
Okay, somebody thinks it's false. Okay, what about others? What's your opinion?
True.
Okay, so we have, okay, most people agree that it's true. All right, so it is actually false. So the question here is about source handling and separation, right? So we are talking about source handling and separation, and curbside pickup is actually a method of is a method of collection. How do you collect your waste, right? So for when we are talking about source handling, so the different methods that we do are like to separate the recyclables. So we use different colored boxes, so in which people could put recyclables, non-recyclables separately, or separate wet and dry, right? So what could be what is compostable and what is non-organic, so we could do that. Or doing backyard composting, or separating what is reusable, recyclable, those things. So all these are the different methods in which we could handle and do separation at the source level. Whereas when we do talk about curbside pickup, it is a method of how we are going to collect it. So either we could, so what are the different methods? One is curbside pickup, so where uh, the uh, the people from the waste management system, so they will come and take your waste from the curbside, which is outside your home. Or the other methods are, you could go and put it in a say a particular location where different houses will have their waste dumped there, and from that but single location it will be collected, right? So we looked at one large container question, right? So that is that is a different way of doing it. So this curbside pickup comes under that, right? So that is under the collection system, not the source handling and separation. So that's why this is a false statement. Okay, so was that clear? So because many of you said true, so I hope now the difference is clear why this is not a method of source handling and separation.
Right, sir. Right.
Okay. Any other questions related to what we saw today? So this is the last question for this week. So if you have any questions, you can ask.
What is our mole balance equation for S2? Question number 2, S2O.
Sorry, question number 2.
I joined late, but
Okay. So the question number 2 was this. So we had 10 moles of A in a particular system. A could be anything, so some compound. So 10 moles of it is in a system at the starting point, and later some 5 moles of it, 5 moles of A were added to the system. So now we have totally 15 moles of this element or compound A, and then there is a reaction that is given, which is 2 moles of A gives 1 mole of B. And the question is, what is the number of moles of B that will be produced in this particular system? Okay, so we from the given reaction we know that 2 moles of A will produce 1 mole of B, which is the same as saying 1 mole of A will produce half a mole of B. Right now in this particular system we have 15 moles because 10 moles were there initially, 5 moles were added later, so totally 15 moles are there. And so 15 moles will give us 7.5 because 1 mole of A will give half mole of B. 15 moles of A will give 15 by 2, that is 7.5 moles of B. So that was question 2.
okay. Okay.
Yeah. So it's a similar question we saw later. So that's why I was referring to this when we solved question 6. So this is also similar to that. So here it was said that 20 moles of carbon reacts with 40 moles of hydrogen. The question was how many moles of CH4 will it produce, right? So in this case, we'll have to first write the balanced equation ourselves. So here 1 mole of carbon plus 2 moles of hydrogen will give 1 mole of methane, right? So that is the balanced equation. Once we write the balanced equation, then it is easy to answer with the given amount of the compounds.
Sir, can you please explain the question number 5?
Question number 5, okay. This one? Is this the question you're asking?
In that having calculations, sir. Question number 4, I think.
Okay,
Sir.
yeah.
This one, sir.
Okay, so this is the question here is we have a certain number of households in a particular colony. We don't know how many, some number of houses are there. And what we are told is the average occupancy rate of this colony is 4 people per house. So we know that. And we are told that these houses in this particular colony generate 3 containers volume of compacted waste per week, right? And also we are given the volume of each of these containers, which is 7.5 cubic meters. So we know total volume of waste that is getting generated in this particular colony. And also and also the per capita waste generation is also given. So solid waste generation rate is 0.45 kilogram per person per day, and also the compacted density is 300 kilogram per meter cube. So this data is given. So the question is we need to find out how many households are there in this particular colony. So how do we do that is first we know what is the total volume of waste. So that is 3 containers of waste, and each container's volume is 7.5 cubic meters. So that is 3 times 7.5. So the total waste that is getting generated is 22.5 meter cube, and this is per week. So that is the total volume. And to convert this volume into the waste, we multiply this volume by the density. So the density is given as 300 kilogram per meter cube. So the product will give us what is the total weight is generated per week. So 6,750 kilograms per week is generated, but we don't want it in per week, we want it in per day. So we divide this value by 7, which gives us 964.29 kilograms of waste per day. So this is the total amount of waste generated from this particular colony in a given day on average. Now the question is, how many houses are there that is generating this quantity of waste? So to do that, we first use this per capita rate that is given, so which is 0.45 kilogram per person per day. So the total waste generated per day divided by the per capita rate will give us how many people are there in that particular colony, right? So that turns out to be 2,143 persons. And now using the average occupancy rate of 4 people per house, so we can use that to determine how many houses are there. So 2,143 persons and 4 people per house, so that tells us there are approximately 536 houses in that particular colony, which is generating this amount of waste.
Thank you, sir. Thanks a lot.
Okay. Any other questions?
Sir, just can you roll over all the questions one by one so that I can record it, because I have missed my class.
Oh, okay, okay.
Thank you, sir.
Actually, we are recording these sessions, and these are being available in YouTube. So actually, you can find the links to this in the course page.
Okay, sir.
You'll
Then it will
find
be fine.
you'll find the session links there.
Okay, thank you. As you can just scroll all the slides as one.
Sure,
And I will
sure,
record you, sir.
sure.
Thank you, sir.
So the first one was about the material mass balance,
So,
right? So we
so,
here asked the question is, four options were there, and which of these correspond to the generation of waste within the given system?
so,
So actually, wastewater and leachate are actually not generated within the system. These are materials that flow out of the system. So that those options are eliminated. Storage is actually what is getting accumulated within the system. So something is coming in, something is going out. So whichever didn't go out, that is getting accumulated, right? So that is what is called as storage. And the question here is, what is getting generated within the system? So that is this biological transformations or incineration, the residue from it. So those are the things that are those are the materials that are generated within the system. So that was the answer here.
so,
And two we just
so.
saw.
Yeah, you have solved it, sir.
Yeah, so 3 is we are talking about large containers for waste collection. So for which of these particular type of housing we use large containers. So when we are talking about large containers, it
Rise,
is
high
corresponding
rise
to
buildings.
large waste generation points.
So,
So high-rise apartments will generate
so,
more waste. So there we use that. Question 4 we saw.
so.
Question 5 is which data is needed to design a good solid waste management system. So we actually need data
All of
on
it.
all these three. How much is generated, how much is collected, and how much is separated, because these three impact different aspects. So like for example, how much is separated will tell us how much we can go for recycling, or how much we can go for incineration, waste to energy, and so on. So how much is collected will tell us the amount, how to design our collection system and transportation system and so on. So we need a good understanding of all these three aspects. Question 6 again we saw just
So,
now.
yes.
7 is again with respect to mass balance. The question is, we are given a system, some inputs and some outputs. Question is, how much is the internal storage? So we just implement our mass balance knowledge. So the change in storage is nothing but the difference between your input and output.
So,
So the total input is given, and that for getting total output, you sum up all the outputs and then take the difference. That will give you how much is getting stored within the system.
just
And 8 is about this economics of transfer station. So the question is, what is this point that is common to these two options? What is the terminology? So that is the break-even distance. So the break-even distance is that point where, or that distance of travel that you have to make to transport your waste, where going for either of the options will give you the same cost, is going to cost you the same. So that is the break even distance. So if the distance is any lower than this break even distance, then your direct haul option will be better, and if this distance is greater than this point, your transfer station option will be better. So that is what this break even distance is. And question 9 is about the different methods of estimating solid waste. So we have three different methods: material balance, load count analysis, and weight volume analysis. So we don't do energy balancing.
So,
And question 10 is what are the advantages of backyard composting? So those are, it provides stabilized material for our home gardens, and two is it will improve our recycling rate because this does not get mixed with our other wastes that we are sending out. And C and D are not actually advantages. So, and question 11 is about whether curbside pickup is a method of source handling
all,
or not. So it's not.
yeah,
It's a
it's
method of
so,
collection. Okay.
thanks a lot for your quick recap, sir. Thank you.
Okay. No issues.
Thank you, sir.
Yeah. Okay. To others who didn't know, we are actually uploading these sessions recorded and in YouTube. So the links are available in the course page. So on the left hand pane, you have the different weeks content. At the bottom, the links for this problem solving sessions. You'll find it.
Thank you, sir.
Okay. If there are no questions, we'll stop the session here. I'll just hang around for a couple of minutes if anyone has a question. If you have no questions, you can leave. Thank you.
Thank you very much, sir.
Thank you.